Hi, everybody. Welcome back to session 2 of our Data Science Workflows in JavaScript workshop series. We're excited to see so many people back for another fun session where we're going to learn different methods and tools to get us from raw data through to data exploration, visualization, analysis. And then we'll be learning a different way today to actually share what you've created using embeds. So today, as a reminder, I want to start with some logistics in case we have some people who weren't in session 1. Welcome. I'm Allison Horst. I'm teaching this workshop series. I'm a data scientist advocate here at Observable. But with us, we also have folks who are going to be here and ready to help you in the chat in case you have questions that I don't get to. They'll also be sharing the materials for the course in the chat along the way so that you have access, for example, to the notebook that hopefully y'all are going to follow along with. And the two people that we have here with us on the call are Robert Casara, a data viz developer, also at Observable, and Wayne Sutton, our community and events manager at Observable. So they'll be watching the chat closely. You can leave questions right in the chat on where you are, where you're called in, but also you can add questions to our community Slack channel. And if we don't get to it during the session, then we will try our best to follow up. Okay, so a few logistics for this session. We're in session 2 of 3 of our hands-on workshop session. So we had one session last week. For participants who have joined us for all 3 sessions and followed along and then complete a task, which will be posted right after session 3 next week, then you have an opportunity to get a certificate for our data science workflows in JavaScript series. A couple of reminders: you'll need an observable account to be able to follow along. So in order to be able to fork your work, which means you're going to make your own copy, and for those changes to be saved so that you can return to them, you're going to need an observable account, which we'll post the link in the chat. In case you don't have one yet, you can sign up. But we'll also be sharing the link to the notebook that you're going to follow along with at a few different places, so you won't miss it. There you go. So there's our first notebook. That's the notebook for today that you're going to fork. And I'll go over how to do that if you haven't forked a notebook before. Again, post questions in chat or in our community Slack. If you haven't joined the community Slack, then we'll post the link where you can join there too. And as a reminder, all sessions will be recorded and we share all of the keys for the session. So if at any point you fall behind or you have to log off or you can't make it for the full session, the materials will all be openly available, including the recording from today's session. Since these are longer sessions, and since I started losing my voice in the last session, and since I'm guessing quite a few people needed to take coffee breaks anyway during the last workshop, we're going to build in a few 5-minute breaks today. So just a heads up, there's going to be certain breakpoints where we take a pause, and then we'll keep moving on to give everybody a little bit of time to take a break, get coffee, whatever. All right. So in the last session, and again, this is kind of the framework for how this workshop series is running. We're kind of going through this standard process for data science, and we're going to be learning different tools and methods at each of these different stages. So in the last session, we learned how to attach a file and then insert a data table cell to take a quick look at it. We use some array methods like array map to iterate through objects in an array and return something, wherein we can do a bunch of wrangling right in there. We learned to visualize data with no code using the observable chart cell, but also eject to plot to observable plot, a visualization library, so that we could write code to fully customize our charts in JavaScript. We did some linear regression using the ml.js JavaScript library, and we also learned how to share notebooks. And since we're working like in the browser, sharing our entire notebook just means making sure that folks have access and sharing the link with them to the notebook. Today we're gonna add a few more. So at the end of the day today, you'll actually have like quite a few tools in your toolkit to do data science workflows in JavaScript and in Observable. I'm gonna briefly review file attachments because there's something I wanted to cover about parsing and data types when you read those in. We're gonna access data from a remote file using D3 CSV. We're going to add Arquero to our list of libraries that we know about and can use. We're going to continue building our skills for visualization, including adding imports and inputs. And I'll describe what each of those are when we get to them. We're going to do some k-means clustering, and then we're going to learn a new method of publishing our content outside of Observable, which is to embed our content. So that's what we have to look forward to today. So this kind of just goes over what we're doing today: accessing data from a remote file, more data wrangling in JavaScript, including with Arquero, interactive exploratory data viz. We'll be reusing community contributions using imports, which are so cool, then doing some cluster analysis, and then embeds. So today I want to first introduce the stars of our show, which are 3 penguin species. You may have, if you work a lot in data science, you may have seen the penguins data used in tutorials and examples, and it's been implemented in a lot of different languages, in R and Python, and it's in Google's TensorFlow data set library. But what we're going to do today is we are actually going to see where these data come from, and we are going to wrangle the raw data, which is not how you might be used to seeing penguins in its curated form. We're going to wrangle that raw data to get it into the form that penguins in its kind of like curated form is usually seen. And then we're going to do some visualization and analysis on it. Because they're penguins, of course, we have to have pictures. The 3 penguin species in this data set are the chinstrap penguin, the Gen 2 penguin, and the Adelie penguin. And so these are the 3 species in that data set. This data set contains observations for 344 individual penguins recorded on 3 islands near Palmer Archipelago in Antarctica. And what it contains is structural size measurements, so measurements for penguin flipper length, body mass, bill dimensions. It also, the raw data, as we'll see, contains a lot of information about like nesting, and if there was egg clutches, and if they hatch for those nesting pairs, and isotopic analysis. So the raw penguins data is actually much larger than the curated version that we'll create. And this, just have to give a shout out to the authors, Kristen Gorman and co-authors, who through the Environmental Data Initiative and as part of the U.S. Long-Term Ecological Research Program, made this data openly available so that we can all continue to learn from it and use it and extend the life of a really cool data set. A couple more pictures because I can't help myself. On the left, I love this picture so much because in this picture by Kristen Gorman, who collected this data, is all 3 of these penguin species in one picture. That guy on the left with his little hunched shoulders, that's an Adelie. The big guy in the middle is a Gen 2. And then the one laying down in the lower right is a chinstrap. So we see an actual photo with all 3 species in it. We could also see from our data what island that might have occurred on. On the right picture here, this is just a stunning photo from Dr. Gorman of Biscoe Island. And finally, this is one of my favorite pictures, the last one I'll share here before we get started, of Dr. Kristen Gorman actually out in the field amongst this horde. I'm sure that's not the right term for a group of Adelie penguins, but this giant group of Adelie penguins actually in the process of recording this data, which is pretty cool. All right, so let's go ahead and jump in. Let's get started with the notebooks. So the notebook, that follow along version, was shared in the chat, but we'll share it again so that people have access to it. And when you click on that link for the blank version of the notebook, you should get to a follow along notebook that looks like this. So you should be looking at something very similar to the notebook that I see here. So cool, that was just reshared. So if you were in the first session, and if this is your first time working in an observable notebook, welcome. Just to give a very brief introduction, an observable notebook is a web-based computational notebook where you can combine your code and outputs and text. And what the few things that you'll need to know to be able to follow along today are these. One is that if we want to add a new cell, all content in an observable notebook is within cells. And if you want to add a new cell, you're going to click the little plus sign in the margin. You can see that it shows up between existing cells. You're going to click a plus sign, and this gets you to what's called our add cell menu. And then from there, you can choose the type of cell that you're adding, which is dictated by the type of content you want to be in that cell. Like JavaScript or Markdown for text, you can add HTML. But there's also specialty cells, like we saw last week for adding the data table cell or the chart cell. And there's also snippets that can get you started quickly with a chart type. So for example, if I wanted to add a scatter plot, this is searchable, so I can just start typing scatter plot. If I select that, a new JavaScript cell with skeleton code for a functional scatter plot is added. And when I run that, which I can do using shift return or by pressing this blue arrow, that actually will run the code, and then I can see that a scatter plot shows up. So those are kind of the main things that you need to work with. So let's go ahead. I'm going to delete this. This might be something we didn't do last week. So if you ever want to delete something, you can go up to this 3 vertical dot menu. You can see there's other options, like you can download different versions of the image. You can link to just a specific cell. You can duplicate a cell. You can comment on a cell. I'm going to delete this cell. So I'm going to delete that cell. But there's your like 3-minute overview of working in an observable notebook. And we're going to be doing a bunch of that today. Okay. One thing before we jump into penguins that I wanted to recap from last week is the idea of data types. And I just wanted to highlight one difference because it was brought up in the Slack channel. If I have an attached file, and you all should have this attached file, which is the Fiddler Crab CSV that we used in the session last week. If I just press insert into notebook, the default is to insert a data table cell, which is great because that automatically shows me what the different variables are in tabular form. It's interactive, so I can like brush over different values, and that'll show me how that range compares with the overall data set. And it also tells me, as you can see up here, it shows me that when I insert using a data table cell from a CSV, it automatically parses the data. So it'll automatically, based on the values in each property or in each column in my CSV, say like, oh, okay, I understand this as a numeric value, or I understand this as a string or as a date in this case. But what I wanted to highlight is that there is another way to get your, so I'm going to go ahead and delete this data table cell. There's another way to get your data into your notebook to load it from an attached CSV file, and that's using a file attachment. But here's what I want to highlight. If I, up in my Files tab, instead of just pressing Insert, which uses the data table cell, if I do copy usage code, so if I go to the 3-dot horizontal menu and then choose copy usage code, then if I go and insert a new JavaScript cell and paste that, then you can see it automatically adds this file attachment line for me, which is going to similarly attach this data to make it available for me to use in this notebook. So maybe I'll call this, as an example, crabs. And then I'll run this. You can see I have my array of values. But what happens is a CSV doesn't have column types like built into it like some other file types would. So what happens is that every single variable is read in as a string or as a character. And then that's it. Like if you notice that your plots are showing up with like very weird axes where every value has its own kind of axis label, it might be because your data is not recognizing numbers as numbers. So I want to show if you are using file attachment to attach a CSV, then if you add typed true within squiggly brackets within that CSV extension, then that's going to parse this. So then we can see that we have some of these like site name, that's still an abbreviation for the site name, that's still a string. But now our other variables are numeric, like we see if we insert using the data table cell. So it's really important to check what type of data you have stored in your different properties. There's a type of function that you can use to actually check. But just keep in mind, if you insert with the data table cell, that's automatically going to parse the different values or properties. If you insert using file attachment, then you're probably going to want to add that typed true so that it's automatically parsing strings as strings and numbers as, or in values as numbers. And of course, you could always parse things later. For example, if it does the wrong thing, which sometimes happens. All right, so that's the only recap thing I wanted to do. So let's go ahead and move on to the penguins. So hopefully everyone is able to fork this notebook at this point. If you haven't forked a notebook before, as a reminder, you need to have an observable account to do this. You can still edit this observable account in Tinker mode without an observable account, but keep in mind that your changes will not be saved. If you're editing a notebook without like your own account and not in your own fork, you'll get a banner up top that says you are working in Tinker mode and your changes won't be saved. But what we want to do is make our own fork so that you have your own copy in your own account where you can save changes. So to do that, as a reminder, let me hide my face here. You can go up at the top of the notebook. There's this little icon to create a fork. Just press that one time, and that's going to transfer you over. It's going to create your copy of the notebook in your account, and it's going to transfer you over to it. And then you'll be able to make edits there, and your changes will be saved. So go ahead, and if you haven't so far, go ahead and fork that follow along notebook. All right, so while people are getting all set up with their fork, I'm going to introduce how we're going to actually access this raw data. So the Penguins data exists and is accessed through the Environmental Data Initiative. So what we're going to do is we are actually going to we are actually going to access data from those URLs. And I'm just realizing that in the version I made for myself, I deleted all of those URLs. So I'm just going to send myself a Slack message so that I have them. Okay, but hopefully in the version, and if somebody can confirm that, that would be awesome. But hopefully in the version that you see, you actually see under step 1, the URLs for those 3 penguin species. And those are the URLs directly from where the penguins' raw data is accessed on the Environmental Data Initiative. So you should have those URLs immediately under step 1. So with those URLs, what we're going to do is we are going to go ahead and use D3 CSV, which is going to fetch. You got the URL. All right, URLs are there. Awesome. Okay, so I only made it more difficult for myself. That's how I like it. Okay, great. So you have the URLs. So, and I just sent them to myself. So we all have the URLs. What you're going to do is first copy that URL, only the URL piece for Gen 2s. And then we are going to create a new, we're going to write code where we actually fetch from that remote URL and then type it. So I'm going to call this Gen 2. And then I'm going to use d3.csv, which is a way that we can fetch remote data. There are other methods to do this. You could just use fetch directly, but this kind of is a user-friendly way to do that for CSVs. But there's also like D3 TSV, D3 text, D3 HTML. So like generally useful methods from D3 for accessing remote data. And the first argument that I'm going to add within this D3 CSV, and make sure you put it in quotation marks, is that URL that's immediately above for those Gen 2s. Now let's go ahead, and after you've pasted that full URL in within quotes within D3 CSV, and again, this is pulling directly from the Environmental Data Initiative where this data lives. If I run that, then what I'll see, and again, you can run with Shift Return or you can press that play button, is I see this array shows up for the 124 Gen 2 penguins that exist on the Environmental Data Initiative on this remote site that we're accessing this file from. So if you have the URL that links to data somewhere living remotely, then these D3 methods are a really, really nice way to access it. But here, let's take a look at this, because this gets back to what I was just mentioning about the importance of like understanding the type of your data. Notice if we just do this, that we can see this because strings are in quotation marks and things stored as numeric values are not. And if we scroll through, first of all, like you might notice there's a bunch of variables in this raw data. There's a study name, sample numbers. The full penguin scientific name is also right next to the species, what region, island, stage, egg stage, if the clutch was completed, dates. And then we get to these structural size measurements that we're going to be most focused on, like culmen length and culmen depth. Culmen is another word for a penguin's bill. So those are the bill dimensions, flipper length and body mass. But notice that these are all in quotation marks, that these are not recognized as numeric values, despite that like all of the values in that column are numeric. And then we have things like penguin sex, we have some isotopic information, and then any comment. So this is what the raw data for the Gen 2s actually looks like. Now, I would like to just automatically have this be parsed. So there's a really cool method also from D3 that we can add right within d3.csv as an additional second argument, which is D3 and then auto type. Notice the camel case here. And what this is going to do is that is going to automatically parse this data for us, similar to if we add typed true for our local file attachment. So you add right within D3 CSV, you have a comma after that URL, and then you have D3 auto type. And now when I look at this, now I can see if I scroll over to those bill dimensions, the flipper length, the body mass, now I can see that these are numeric values. All right, so this is cool because this gives us a very quick way to access remote data just using a URL and to parse it. So what I want to ask you to do is I want to ask you to go ahead and do the same thing to create, to access and parse the data for adeles. We'll call that adele, and for chin straps. So go ahead and take a couple minutes using the same method that I used here to go ahead and access the adele and chin strap data using those URLs immediately above. All right, so I'll go ahead and get started on my end so you can follow along with me if you're a little bit stuck. Otherwise, feel free to keep working so that you have these 3 different data sets for each of the 3 penguin species that live remotely on the Environmental Data Initiative repo. So here again, I'll use D3 CSV. I'm going to give this my link to my URL for the adele penguins. And then I'm going to add D3 auto type, remembering that that's in camel case. One thing that you might notice here that I'll just highlight because I'm seeing it on my end is I can see I just ran my code to add that a deli and I can't see the code. You can pin or unpin cells to make sure that the code is always showing or not showing. If I want my code to be showing, I can use this little expand but arrow, and then I'll see this pin. And here I can just choose like click that pin button. And if the pin is blue, that means that the code is going to stay there. So it's going to remain visible. All right. So a couple of questions here that I'll take while folks are still working on getting those data sets. Is there a way to permanently store those CSVs in the notebook in case those URLs go offline in the future? Yeah, great question. Thanks. So you can, similar to how you might see the fiddler crab size CSV attached to this notebook, you could, if you wanted like a static version of those CSVs as a downloaded file that you had locally saved on your computer to be attached to this notebook, detached, you can attach files in our files pane. So to do that, you click on the little paperclip icon up here that opens the files pane, and then you can choose that plus sign, and then you can select the data that you want to actually attach to that files or to that notebook, excuse me. All right. Ooh, okay. So now, okay, so I'll go ahead and finish up. So hopefully people in the meantime have been able to access all three of these from the Environmental Data Initiative. I'll go ahead and just get my chin straps. So now I'm going to paste my URL. I'm going to use D3 auto type. Okay, and now I can see that I have my data for my Gen 2s, my delis, and my chin straps. These all now exist in my notebooks as arrays of objects. As a reminder, an array is a way to store multiple elements in one data object. They don't have to have the same type. In this case, all of the different elements are objects where each object contains properties and the associated values for different characteristics or identifying information of individual penguins. So for example, if I look at this chin strap array, and if you're wondering how I actually saw that, if you want to just expand the array to visualize it, you can click on the arrow just to the left of array, and that'll actually expand it to give you a preview. So each of these objects, where objects are bound by squiggly braces, curly braces, the overall array, when we'll use this later, is bound by square brackets. But each of these objects contain these properties. So like study name, species, stage, Coleman dimensions, and the associated value that was recorded for that penguin for that property. So you might think about this as a data frame, but instead of having each of the variable names just at the top of a column, you actually have the variable names placed immediately next to the value for that variable. All right, so now we have all of this data. We're going to combine it and do a little bit of wrangling. And after we do some wrangling, both in plain JavaScript using array methods and using a really cool library called Arquero, then we'll take our first break. So you got a break coming up in about 10 minutes here. So what we want to do is these data sets, first of all, they have the same, each of these data sets that we've stored now, Chinstrap, Adeli, and Gen 2, they have the same variables in the same order, each in an array of objects. And the first thing that we want to do is actually combine these into a single array of objects where we're essentially like stacking these each on top of each other. So it's kind of like a row bind function if you're working in R Python. So I'm going to do that by creating a combo version, penguins combo. And then I'm going to say depending on which one I want to be the first in the series, I'll say I want the adeles to be up top in this new array of objects. It doesn't really matter. But I'm going to say, starting with adele, I'm going to use this concat method, which allows us to combine elements from separate arrays. And then I can just give it, since again, these have the same properties, same in the same sequence, I'm just going to say, I want to concatenate that with gen2 and then chinstrap. And now what I have is an array of all 344 penguins that were recorded at the Palmer Archipelago Islands. And I can expand that, but I see this number gives me a good hint. I know there should be 344 penguins total. This combines them all. It keeps the type that I want. But we also have like a bunch of, for our purposes, there exist a bunch of variables in here that we're not going to use, that might not have convenient names, or that might not be in the format that's useful for us. So what we're going to do is we are going to do the following in JavaScript. We are going to create a new array that contains a simplified version of this data that contains only the variables that we want in the format that we want them. And the variables that we want are the species that the penguins were recorded on. There's 3 of them: Bisco, Dream, and Torgerson Island. There is cool, yeah, seeing people make other suggestions for how to combine things. Awesome, thank you. We're going to keep these 7 variables: species, island, sex, the build dimensions, Coleman length, and Coleman depth, but we're going to rename those. Body mass, we're going to rename that, and flipper length, also rename to flipper length. So let's go ahead and do our wrangling here. Now, as a reminder, we are going to use the map method, which we used in session 1. The map method has a specific job, which is to iterate through each element in an array and then return in a new array the outcome of some function that's applied to each of those different elements that it's incrementing through. And in our case, those elements that it's incrementing through are each of those individual objects for each individual penguin. So what we're going to do is we're going to use map to iterate through each of those penguins, the information for each of those penguins, and then we're going to write a little function that only returns some of the variables or some of the properties for each penguins and renames them, and in one case does a little bit of wrangling. So let's go ahead and create penguins as we might more commonly know them. So here, I'm going to call this penguins. As a heads up, there is a built-in version of penguins like in Observable, like there are in a lot of other platforms, but we're making this on our own. So I'm going to start from penguins combo. So again, this is going to really highlight, this lesson is going to highlight like me being right on the fence between camel case and snake case. So anyway, use camel case for penguins combo. I'm going to use snake case for some of these variables, but that's really so it matches kind of the standard way that penguins tends to show up, which is with variables in snake case. Okay, so I start with penguins combo. I'm going to use map. And then this is going to iterate through each object. And then I'm going to give map the function that I want to actually return something from and put in a new array for each of those objects. I do that. I'm going to do that. You don't have to do that. I'm going to do that using an arrow function, which is just a concise way of writing a function where D is, this doesn't have to be D. You'll oftentimes see D. D is saying like, for each object. So this is like the input parameter for the function. And then on the right-hand side is going to be what I want to return for each of those objects that I'm iterating over. But this could be like banana split instead of D, as long as where we access objects or where we access properties, we also refer to the object as banana split. So there's nothing special about D, but it is commonly what you'll see. So here, I'm going to say, I want to return for each of those objects I'm iterating over, I want to return a new object in that output array. We have to do that, we have an outermost set of parentheses and an innermost set of curly braces. And a really common question is, why do I have, if curly braces is going to return an object, why do I need that second set of outer parentheses? And that's because curly braces will create an object, but they can also create other things in JavaScript, like the body of a function, for example. So adding this second set of parentheses outside of those curly braces is letting this function know what I'm returning is an object containing these things, not one of the other things that can be created using curly braces in JavaScript. I'm going to press enter here to give myself a little bit of space, and then I'm going to start saying what I want to be returned from each of those objects that I'm iterating through. So in this step, I'm going to do some renaming, I'm going to do some selecting of columns, and I'm going to do some data wrangling all in one place, which I think is like a nice and concise way of working. So the first one I'm going to pick is species. So this is what the property name is going to be in the new array that's created, penguins. But you'll notice, and I'm going to go up here, if I'm looking at penguins combo, the current species column doesn't just say Adelie, which is really all we need. We just needed to say Adelie, Chinstrap, Gentoo. It says Adelie, penguin, Pygocellus adeliae. Haven't really figured that one out yet. Pygocellus adeliae. So it has like the actual species name we really need, Adelie, but then it has penguin, and then it has the scientific name. So what I'm going to do, and again, there's a bunch of ways to do this, is I am actually going to access the value from species for each of these objects. But what I want to return is just the first element if I split this up based on where different spaces are. So if I split this up, this string, if I split this up based on anywhere there's a space, and then I only keep the first element from that broken up series of strings, then what I'll get is what I want, which is Adelie. Again, there's a bunch of different ways to do this. I'm going to use the split method. So the first thing that I'm going to do, so that's a little preface. So to get just that species name Adelie, or Chinstrap or Gentoo, it's always the first term before the first space. I'm going to first say I want to access the value in the species column of that object. But if I just do that, then this works. This is just returning species. This is a new array that just accesses the species value and returns it with a property name lowercase species. So that works. But then I'm going to do some wrangling here. So after this, I'm going to use the split method and say I want to split anytime there's a space. I'm going to split this string up anywhere there's a space. Now, if I run this, and you don't have to run this every time, but just show you what's happening, this is actually, since it's Adelie, penguin, Pygocellus, adeliae, there's actually 4 elements if I break it up by spaces, right? Which is why we see this array 4. We only want the first element, which in JavaScript, as a reminder, uses 0 indexing. So to just grab the first element there, I'm going to use square brackets immediately after, and that's just going to pull the first element from that array of the split up strings. So now when I look at this output, then you will see that now I have species, which is how I want this property to be named, and only the first part. And if you scroll down, you would see that that's also true for Chinstrap and Gentoo that exist there. Okay, so let's go ahead and add some more properties to this object that we're returning. I'm going to have a property called island, which is just pulling values from the existing capital island. So this is doing a select of island and renaming it to be lowercase. I'm also going to do some wrangling with the sex variable. So whether a penguin was recorded as male or female, but within that variable, there's also a couple times, and you would have, if you were doing this on your own, like deeply explored the data. So you would have seen this when you did like faceting. There's also some places where instead of just missing, there is a period added. So we're going to convert those to null so that anywhere where the sex value is missing, it's actually a null value here. Here's how I'm going to do that. I'm going to say, okay, I'm going to have a property called sex, which accesses the value of the sex column. But what I'm going to do here is I'm going to write what I'm going to use the ternary operator, which is a way of writing an if-else statement in JavaScript. So what I'm going to say is if the sex value is null, so if that matches null, or, so I use the double pipe there. So that's the double vertical line on your keyboard. That vertical line, if you haven't used it before, is the shift option on the button immediately above your return key on the right-hand side of your keyboard. So if the sex value is null, or if the sex value is stored as a period, if either of those is true, and this is a ternary operator works by asking like, ask a question, and if that's true, do this first thing immediately after the question mark. So if that's true, I'm going to return null. But if that's false, I'm going to return just the existing value of sex. So what this is doing, and maybe we can, I know this code is a little bit involved, so maybe we can just like copy this code into the chat. Actually, I'll go ahead and do that just in case it spares anybody some frustration here. So that's the code that I just wrote there. And if I run this and I look at my code, then I'll see that, and I run my code, then I'll see that I have sex here. One final thing I might want to change, notice that all the values where this is missing are null. One thing I might want to change is I might want to convert this to lowercase. So that's the final thing that I will add here is if it's not null, then I want it to be the value that's contained in that sex property for each penguin. And I'm going to add this method to lowercase. Notice the camel case there. So the L and the C are capitalized. And when I run that, then the values of that variable are going to be converted to all lowercase. So if I check out what this looks like now I have this column cleaned up with all of my values in lowercase or as nulls. All right. I feel like there's so much wrapped up in this one data wrangling example. I love like how much wrangling you can do in like very small examples of JavaScript. That's an aside, but I just think it's very cool and fun. All right. Now, the last 4 variables that we're going to add to this are the variables for those bill dimensions, the body mass, and the flipper length. So I'm going to do one of these, and then I'm going to have you all add the rest. So I'm going to add bill length. I'm going to have this property in my newly returned array be stored as bill length millimeters. And this is going to contain the values that exist previously in my variable that's called, and if I scroll over, you could also check the names of these, but this is called Coleman length millimeters. So what happens if I do D Coleman length millimeters is I'm going to have a problem, is that this is seeing a space that it's not happy about. Even if I put this in quotations, I'm still getting an error. So here's a reminder that if you have valid names that can be used with this dot notation to access values from an array of objects or from an object, you can use this dot method. So things that are like no spaces, no unexpected symbols. But if you have a variable name that you want to use that does have some of those unexpected symbols or spaces, then we're going to use bracket notation. Then you can access that still by having whatever you're using as the parameter name for your object, followed immediately, no space by square brackets, and then the name of that variable. And then if I check this out, I can see that now I have bill length added as a number here with that name that I gave it. So now I'll go ahead and let you all take a minute or two and also add the variables for build depth in millimeters, body mass in grams, and flipper length in millimeters. So give that a shot, and I'll start in a minute to give people some time so that then we have this nice array of cleaned up, simplified Penguins data that contains these 7 variables that we're going to continue working with. All right. So I'll go ahead and start writing these out. I'm going to add build depth in millimeters, and that is just going to be accessed from the Coleman depth millimeters. I'm going to add body mass grams, accessing from body mass grams, and flipper length millimeters is accessing that flipper length variable. See a good question in here. All right, so here is that what my full wrangling looks like. And if I expand this array, now I can see that I have all seven of these variables with these nicely renamed dimensions. I have just the species first name, a jelly chinchapper gentoo, and I have this reformatted column for sex. So a whole bunch of wrangling right in a really condensed place. Okay, so there's a question here, which is a really good one. What's the difference between a double equal sign and a triple equal sign in JavaScript? Which, if you're coming from different languages, maybe this triple equals, like, what is that? So these are called the loose equality operator is the double equals, and the strict equality operator, which is the triple equals. And the difference is in if they try to coerce the data to the same type before doing a comparison. So the way that I think about this is, in order for true to be returned from a strict equality operator, the triple equals, the original values you're comparing have to be equal in both value and type. But if you're using the loose equality operator, the double equals, then it will try to convert the values to the same type before doing the comparison, which is kind of strange. So let me just show a quick example here, and then we'll do our first break. If I, in a new JavaScript cell, and feel free to try this if you want, if I do 2 double equals and then in quotes 2, you might be like, those do not match. One is a number and one is a string. But if we run that, then that returns true because it's using the loose equality operator, which means that it's going to try to coerce these to the same type before doing the comparison. But in contrast, if I do 2 triple equals 2, this will not try to coerce them to the same type first. So if I run this, then this is going to return false. So in summary, the strict equality operator tries to convert values to the same type before it does the comparison. The strict equality operator does not coerce them to the same type before doing the comparison. So in order for a strict equality operator to return true, things must match in both value and type for that to be true. Great question. All right. Let's go ahead and take a break. So let's take a break until 9:55. I'll be back here in 5 minutes to get started with some data wrangling. That's going to feel great for people who have been working in like dplyr and the tidyverse or in pandas, which is using Arquero. So I'll see you in, let's do 9:56, full 5 minutes. I will see you in 5 minutes. Okay, welcome back, everybody. All right, so now we're back on after a little break. Hopefully, people got coffee or whatever else you needed for 5 minutes. Now we're going to get started. We're going to start with some data wrangling with a different JavaScript library. We are going to then move on to exploratory interactive visualization before getting into k-means. Okay, so one thing, I built in a little checkpoint into this notebook so that if you got lost at any point previously and like penguins didn't work to create, or it doesn't look how my version of penguins looks, so that you can continue to follow along with the rest of the workshop, I made a little checkpoint where you can go ahead and use the same version of penguins we're doing. So right above the section that says meet Arquero, if and only if you did not get penguins working doing the wrangling steps we did above, uncomment this line so that you can do that by deleting those 2 slashes and then running this code. And that will create a version of penguins for you that's exactly the one that we're going to be working with moving forward. Now, what you might get if everybody tries this, just a heads up, if you have multiple things called with the same name in a notebook, notebook's not going to be happy. Everything has to have its own unique name. So what I recommend is if you're using this method to get the same version of the data that we created before, and again, this is only if you couldn't get penguins working above, is if you tried to create penguins above here and it did not work, then just change this to like penguins broken. And that way you'll have this working version of penguins down here, which is exactly what we're all going to move forward with. Again, you only need to do that to get caught up if your penguins wrangling up here didn't work. If your penguins wrangling did work up here and you have penguins the same way that I have it, then you can just leave this line commented out because you have the same version of penguins that I'm going to be working with moving forward. All right, so hopefully that gets everyone caught up. Again, if your penguins broke before, uncomment this line, make sure you don't have anything else named penguins, then you'll be back up and running with the same version of penguins that we have. Now, I did want to introduce, I think that like wrangling just in JavaScript like we did above is a pretty nice and concise way to do a bunch of steps in one. But if you're more familiar with using things like dplyr or tidyr or pandas, then maybe you're more used to working with like chained verbs to do different wrangling steps. And if that's how you want to work, awesome. There is a really great library to help you do that, and that's called Arquero. There are other really good libraries in JavaScript that feel very similar to like tidyverse style libraries like tidy.js. We're going to use Arquero today, but know that these different libraries exist. But the first thing that we're going to learn about is how to import things from other notebooks. And importing is awesome. So basically what importing does is if you have access, meaning like you can view any other notebook of tens or hundreds of thousands of observable notebooks, including from people who are like making the most awesome things in D3 and JavaScript, that you can access pieces of their notebooks for use or reuse or iteration directly in the notebook that you're working in, which like will always feel a little bit like magic to me. So I'm going to show you an example of what that can look like. And then hopefully when we see import throughout the rest of the day, hopefully this will make sense. So I'm looking at, for example, this awesome zoomable sunburst chart made by Mike Bostock, where you can like scroll in on different sections. I'm going to put the link to this in the chat for our workshop because this is going to be important for us. One thing that I notice when I look at the code for this is that this has a name, that this is called chart in this notebook. So what I can do if I want to use or reuse or just transfer this over to my notebook is I can copy the slug for that notebook, which in our case is anything after observablehq.com. So for us, if I'm using this case, that's at D3/zoomable sunburst. So it's giving you the account and then the slug for the URL. And I can import a thing or multiple things from that notebook, and then I have immediate access to them. So I'm going to show you an example. I'll just put it right under Meet Arquero here. This is like Meet imports and observable. I'm going to insert a new JavaScript cell, and I'm going to say import, and then I'm going to give it the name of the thing that I want to import. This could be text. It could be color schemes. It could be a logo image. It could be a function. It could be a function to make an interactive chart. Like pretty amazing, the like breadth of things that you can import. I'm going to give it the name of the thing that I want to import between curly braces. So I'm saying import chart, and then I say from, and then within quotation marks, I give it just that slug. So in this case, that at D3/zoomable sunburst, which you can see from the link that I shared in the chat here, is anything after that observablehq.com in the URL. And so if I run that, then I have, this is imported for me to use in this notebook. You might be like, where's the chart? Well, this imports it, but then I actually would have to like use it somehow for this to show up, which in this case, if I just call chart in a JavaScript cell, and if that was too fast, again, to add a new cell, I'm pressing this plus sign, choosing JavaScript. And if I call chart here, then I have this zoomable sunburst chart right in my notebook, including with all the interactivity maintained. So this is an example. I'm going to delete this from my notebook, but this is just to highlight that you can import from whatever notebook you have access to get content from either yourself or your team if you have a bank of reusable contents, or from the expansive community of observable creators so that you can add them to your notebook or reuse them or build on them in really cool ways. Okay. Cool. Oh yeah. So thank you, Cobus. So I want to highlight this because this, if writing the import statement, that's tedious. You can also get the import statement from whatever cell you want to import by clicking that 3-dot menu to the top left, in the top left of your cell. And there's an option to copy that import statement that you can then paste in your notebook. I truly, like, every time I use imports, I'm like, this feels a little bit like magic. So I'm going to go ahead and I am going to delete this just meant it as an example, because I want to show other ways that we can use this that for our purposes will include getting different pieces from a library, which for us is Arquero. So if you scroll down, then hopefully that explains what this is doing, is that there's actually a notebook that contains the different functions like verbs for like selecting things and renaming things and filtering things that exist in this AQ piece of Arquero's notebook. And there's also some functions for doing operations that exist in that notebook. So we're importing both so that we have access to them. All right. And the Arquero library is really a friendly one. One thing to know is that to use those Arquero verbs, we're going to first convert our array of objects into an Arquero table using a from method within that Arquero module. So to do that, first I'm going to call this penguins table. And I'm going to use the from method in that Arquero module that we've imported from that notebook. And then I'm just feeding it that penguins data that we had created. And you can see that this is creating a table for us. If you wanted to view this, you can tack view onto the end, .view. I actually just want this table to be stored, but you can, and we'll add this to the end of our wrangling step so we can explore at each step. But this gives us another way to get a nice tabular view if we're working with an Arquero table. But I'm going to work with that. And so now I have this Arquero table. So I want to do these steps. We're going to roll through these pretty quickly. We are going to first filter to create a subset with only female penguins. Then we're only going to select columns for species, bill depth, and bill length. Then we're going to add a new column with the bill dimension ratio. And then we are going to group by species and find the mean of the bill ratio by species. Could we do this all in just JavaScript outside of Arquero? Absolutely. This is just another way that you can do data wrangling in JavaScript using a library here. So I'm going to start with penguins table. So I'll start with penguins table. And then I'm going to use dot filter. And then I'm going to give it an arrow function that says I only want to keep objects or keep rows in this table if the sex matches female. So I'm going to write a little arrow function that says only return those rows if sex matches female. What I'm going to do is I'm going to tack view on at the end here at this point, just so we can like quickly get a look at what's returned, which I think is always a good idea when you're doing a lot of data wrangling steps in sequence, is make sure we're looking at actually the results of each step. So we see we have only female penguins now. Cool. But I don't just want to stop there with my wrangling. I'm going to add another wrangling step. I'll keep view here, just tacked on at the end, where I'm going to use select, where select is going to only select certain columns. You can do it by the column number. We're going to do it by column name. So I'm only going to select, and I'm going to put these in quotes here, which might be a little bit different than ways you've been working in other languages using select. This is how Arquero works. I'm going to select species, bill depth, millimeters, and bill length in millimeters. And again, I'm going to run that. Notice that this nicely formats my code so that it's vertically arranged for me, which is great. Now I only have these 3 variables. So this feels, again, hopefully for those of you who might be more familiar with sequential steps using functions that are verbs, this might feel more familiar. So that's just selecting those 3 columns. The next thing that I want to do is add a new column that contains the ratio of the bill length to the bill depth. So I'm going to add a new column using derive. This would be like a mutate in dplyr, where I'm going to say there's this new property. So this is in curly braces. There's this new property that I'm going to give a name of bill ratio. And then I'm going to give it a function that actually is going to calculate and return that value of the ratio. So here, this is going to be a little arrow function where I access bill length in millimeters, and then I divide it by the bill depth in millimeters. I can run this and see that now I have a new column added called bill ratio. So derive, again, adding a column that's derived from existing columns. And then the last thing I want to do is find these mean values for bill ratio by group, which means that we need to let this code know, well, what is the variable that we want to create those groups within? So I'm going to add a group by and say group by species. Now, this doesn't actually change anything looks-wise about the table that's returned. But what it does do is under the hood, invisibly, it's letting Arquero know, like, whatever happens next, I want you to recognize that we're calculating this within each of those groups for that variable. So this is going to calculate in this next step the mean bill ratio for each of the different species, which is my final step, which is a roll up. So this is similar to a summarize in dplyr, for example. And I'm going to give it, again, this new variable. So we have curly braces. I'm going to call this mean bill ratio in snake case. And then again, I'm going to give it an arrow function to say what I want to actually calculate. So I'm going to say I want to calculate I can use D3 mean here. I can also use these mathematical operations that are built into Arquero. Op mean, that's pulling the mean function from that op module that we also imported for Arquero up here. So I'm going to say use that mean function applied to the bill ratio variable. And again, since we have this group by, then it's going to do that by species. So here, now what I have is I have my little table with summary values by species for that newly derived column of bill ratio that we found the mean of. Yes, I will absolutely copy my code. There's a request to copy the code over and share. So there is the code that I just ran. And as a reminder, if you're getting that error, make sure that you have ran this line to create an Arquero table from the penguins array of objects, because that's what these Arquero verbs are expecting. And make sure that when you're running this, you're starting from that penguins table. All right. Cool. So now we've done wrangling. We've actually done like a bunch of different wrangling steps in multiple ways. We've done selecting and renaming and deriving new columns, both in like plain JavaScript and in Arquero. There are other options for data wrangling in JavaScript. These are just a few. But now that we have penguins in good shape, let's go ahead and start making some visualizations. As a reminder, I want to start by revisiting the chart cell and observable plot. If you weren't here in the first session, Observable Plot is a JavaScript library built on D3 that lets you quickly make, but also have full customization power over charts in JavaScript. It's built on D3, but D3, if you're building kind of a standard bar chart, you might still be writing a whole bunch of lines of code. So Observable Plot adds a layer of abstraction that lets you more quickly create some sort of standard chart types, but then like customize and extend those however you would want to, because it is just in JavaScript. The chart cell is something that we used last time too. The chart cell is a specialty cell in Observable that lets you create a chart with no code, but you can also eject to JavaScript. So let's go ahead. We'll start with a chart cell, but then we'll eject to JavaScript to do a little bit of customization. So I'm going to start by creating, and we're going to work from penguins here. So we're gonna start from just penguins. We did our Arquero stuff. We're going back to just using the penguins array of objects that we had created. I'm going to go to my add cell menu, and if I start typing chart, then this first option that shows up, quick plots without code, that's where we're going to start. And I'm going to select my data source of penguins. Notice that any data structure or data object that we've saved here is going to show up here. I'm going to choose penguins, and then I can choose my variables that I want to create without any code. I'm going to choose on the x-axis, I'm going to choose bill length. If you only choose a single variable, a histogram gets created. On the y variable, I'm going to choose bill depth. Make some assumptions based on the variable types about what kind of chart makes sense. So here we get a scatter plot. And then I'm just going to choose color based on species here. So here we can see both the within group increasing linear relationship between bill length and bill depth, but also across groups. If we had ignored species, then this gives us a nice example of Simpson's paradox, where we would potentially infer the opposite of relationship for bill dimensions from what's actually happening if we omit this important variable of species. All right, so we can really quickly create charts in the chart cell. There's options for customization. You can facet this. You can choose reducers for your different variables. But what we're going to do is we are going to eject this, because this is under the hood observable plot code, and we can get back to observable plot code and then continue customizing it beyond what we might be able to do in the chart cell. So I'm going to choose my add cell menu here and then scroll down to the gold convert to JavaScript option. And you'll see that it makes a copy of your chart, but instead of then having this like GUI interface for updating your chart, then you have the actual observable plot code, which you could write from scratch or starting from a snippet. But let's just see a few ways that we could customize this. Maybe I want, instead of an outline stroke, I just want to have the fill to be species. So these are just like my aesthetic choices based on different variables. I can make this into more of a bubble plot where dot size or radius depends on another variable, using the R channel for radius. So maybe I want R to depend on body mass in grams. You can see that scale is not hugely different, but the points are different sizes now. We'll learn how we can exaggerate that in a minute. I could change things like opacity. So I could set this to 0.5 for opacity as a reminder. 0 is completely transparent. 1 is completely opaque. Anything between is along the spectrum of translucency. But now we might want to do like some things outside of just these aesthetics applied to this certain mark. I can layer marks on top of this. So still within my marks section, but outside of plot dot, if I add plot frame, for example, that's going to add a frame around it. You could add linear regression marks to actually show the models across and within groups for linear regression by ordinary least squares. So you can layer compatible marks in the same observable plot area. But let's go ahead and do some more customization that we didn't do last time. Let's go ahead now outside of marks. So not just applying this to like my dot mark. Outside of marks, I'm going to do some kind of global option adjustments, where the first is that I'm going to give it a new color scheme. So I'm going to say for color, I actually want the range of colors. This is how I can specify a custom color scheme to be, notice square brackets here, teal, dark orange, and orchid. You could also choose hexadecimal color codes or any other web compatible or web understood color names. So that updates my color scheme. Notice that this automatic tooltip is added, which is great. That's just added here with tip true within that dot mark. But I also want to change the scale of the radiuses. So I'm going to add this other channel for R, or this customization of the R channel, where I'm actually going to say I want to specify for the range of values that exist within the body mass variable, which is what R is mapped to. I actually want the scale of those dots to range from this size to this size. So that's the two things we're going to do here. So the domain is going to be the range of, or the extent of the values of the actual variable that we are spanning. So here I'm going to say the domain is the extent of those body mass values. Here, the way we're going to do that is using D3 extent that gives you an array from the minimum value to the maximum value. And then I need to give this an array of values. I'm going to use map to get the array of values just for body mass from penguins. So I'll use penguins map, give it a little arrow function to get just the body mass in grams. So here, if I run that, that doesn't actually change anything. But let me put this line in the chat because I ran through that a little bit quickly. And now what I want to do is say, though, for that extent of values, here's the range that I want R to actually vary over. So that's where I give it the range as another argument. And I give it an array of values over which I want the sizes of those bubbles to actually vary. There's different like interpolations for how that range changes. If it's linear, for example, across like both colors and sizes. So there's a lot of different ways that you can customize this. But this just gives you an idea of like the level of customization that you would have working in observable plot, both within specific marks, but also kind of applied more broadly to the channels. You can add grids, you can change the tick mark numbers, you can change the labeling, you can change the fonts. So you really have full control over what this looks like. All right. So first, like also importantly, is it does look like, at least for build dimensions, there are kind of noticeable differences or clusters for build dimensions for these different species. So that's a hint that maybe our clustering is going to yield some interesting results. The next thing that I want to do is, so we have already seen an example of import to get different pieces from a for Arquero, so you can get like different functions from another notebook. We're gonna here get a function that creates a nice pair plot from this notebook, from the observable account auto plot matrix, which is a really nice one. So I'm going to go ahead and just show you where this lives. So this is the auto plot matrix notebook, and I'll drop the URL in the chat to get there in case you want to take a look. But what this does is, this is really nice. Phil, one of our data visualization experts at Observable, has built this really nice pair plot and inputs associated with it. So like, and selectable widgets that's going to quickly let us make a pair plot that breaks down distributions and relationships for the data in our penguins data really quickly without having to recreate this from scratch. And notice here that this is called chart. So just like we had imported chart from that D3 notebook previously, we're going to import chart here. We're going to import plot matrix because that's what we are told to do in this notebook somewhere. We're going to import plot matrix to actually access every piece of this, like create the notebook, and then we're going to have the inputs associated with it. So this code that you should have already in your notebook is doing a couple things. It's importing that plot matrix function that combines that pair plot and the inputs associated with it. But it's wanting this with data is saying, whatever data you feed into this, I want to be named data. So here, what we're going to do, our data is currently named penguins, but I'm just going to make, so that we can use this, I'm going to make a copy of penguins called data. Am I back? I hope I'm back. Okay. All right, back. Okay, cool. Sorry about that, everybody. Hopefully that was only for a minute. So I've made, in case I was gone for that part, I'm making a copy of penguins that's called data here. And since pair plot is expecting data called data, then I can just go ahead and plug that into the plot matrix function that we just imported, feeding it data, which is our penguins. So here, this is cool. Like, all I had to do to create this interactive pair plot for my penguins data is say, since I had imported plot matrix and then I feed it data, which is a copy of my penguins, now I have a nice pair plot showing the distributions, the counts, and the relationships across my variables. And on top of that, plot matrix also has built into it these inputs that let us choose what actually shows up here, which is wild and awesome. So I can pick which variables actually get shown and compared for this pair plot, which is super cool. I can also change what channel I actually, or what variable I want to be used for the color. Total magic, right? And like the number of times where I'm like, oh my gosh, this other brilliant person has made this amazing thing, and I can just use that with my own data in one line in my notebook is like at least daily. It does truly feel like magic at my fingertips. Again, so this is using imports so that we have immediate access to that plot matrix. We are giving it the data with the name that it's expecting, and then we get this nice chart that's showing us again that, yeah, there might be these clusters that exist for like body mass. So we might be seeing these clusters. This is grouped by species. So body mass and flipper length looks like there might be some clustering, different clustering for build dimensions, for example. So we can start seeing like it looks like there might be some clustering happening. So now the last thing that I wanted to show here before we take another break and then do k-means in the final 30 minutes of our session is I want to revisit interactivity using observable inputs. And we already have a preview. We did this in session 1, but not in a way that was like really functionally useful for for exploration. But here's an example. Like these are inputs. This fields and color, these are observable inputs, which are a really lightweight way to add user interface elements and then quickly connect those to your chart or your text or tables that you've created to make them interactive in 2 steps. So in this workshop, I want to revisit that, but using inputs that actually are helpful for us to go ahead and explore the data. So what I'm going to do first is I am going to use the chart cell to create a faceted histogram of body mass by species. So that's my starting point. And then I'm going to connect this to the input so I can actually choose the variables that I want to explore in those faceted histograms. So I'm going to do that by first, from this plus cell menu, I'm going to start typing chart. Remember the add cell menu is searchable. And I'm going to select my penguin. So we're back to just penguins here. And then I'm going to choose on the x-axis. We're going to start with body mass. Cool. I'm going to update the color by species. This is kind of a redundant aesthetic, but we're going to do it anyway for clarity. So here I have a stacked histogram for body mass by species. Sometimes stacked histograms are what you want. Sometimes they can be a little bit challenging to interpret within group distributions. So the last thing I'm going to do in that chart cell is use facet Y, and I'm also going to facet by species here. And I could customize this if I wanted to. You know, I'd increase this margin so that species isn't overlapping with the different group labels, for example. But we won't worry about that for now. But what I'm going to do is say, like, you know what? I want to connect this to inputs to make this interactive so that I can actually choose if I want to view the distributions for body mass or flipper length or build depth, for example. I want to be able to quickly toggle between those. To do that, I'm going to eject to JavaScript. So I'm going to scroll down and I'm going to say convert to JavaScript. And this gives me my code that's used to create this chart. But now what I want to do is notice here where this body mass variable shows up. That's just the variable name. So if I could have an input that actually just switched those things based on my selection, then I would only have to change that here. And that's what we're going to do. So I'm going to create that input immediately above this chart. So I'm going to go up to my add cell menu and I'm going to start typing radio because I want to add a radio button input. And then here is where I can customize this. I'm going to change the name of this input. That's what I'm going to refer to later. That's where my value is going to be stored, to like choose variable. And then I'm going to give it the names of the variables that I might want to select from as this x-axis variable. So I'm going to change this to like build depth millimeters, and this is an array, build length millimeters, and these match exactly the way that this shows up in my array from penguins. Flipper length millimeters, and body mass in grams. And then I can change how this is labeled to select variable. And this value is the one that's going to be automatically selected if you refresh the page. So I'll make that body mass gram. And I'm going to go ahead, I'm going to copy this code into the chat in case any folks got lost. That goes in a JavaScript cell, and that's how you can create that. And as a reminder, this is actually storing whatever the selection is as a value that I can access anywhere else in my notebook. So if I call choose variable, this is a string where the value is currently body mass in grams. But if I switch to bill length in my input, then that string is actually updated to whatever that selection is. So that's step one. You create a lightweight user interface element that's customized for your needs. And the next step to make my chart interactive is instead of having the x-axis variable be this absolute value of body mass in grams, I'm going to say, actually, I want this, whatever is chosen as x, to be whatever that input selection is, which I had named choose variable. And as soon as I update that to choose variable, this is now connected to the value of that input, which means that I can then quickly toggle between my different variables. I'm going to unpin this. I'm going to delete that. Now I can toggle between these different variables to very quickly explore distributions by species across the different variables based on what's most interesting to me. If you send this to somebody else, like send them the notebook link, they can independently explore these things. You don't have to be seeing the same thing at the same time. So there's independent interactive data exploration. All right. So that's the only example we're going to do for time. In the key, there's another example of using a range slider to determine histogram bin widths, but you can also use that to like zoom in on certain time ranges and time series data. But what's really nice about inputs to make interactive charts, like close to out of the box in JavaScript and in observable notebooks, is it's always those two steps. So you create the user interface element with inputs from a snippet, customize it how you want it. That's going to show the user interface element. It's going to reveal the widget and also store the current selections. And then second, you just connect the name of that widget to an element of your chart that you want to be determined by that selection. And then you immediately have an interactive chart that you can share with anybody, which I think is really, really super nice and avoid some of like the common frustrations with both creating and sharing interactive visualizations. All right, we are really close to being done. So let's go ahead and let's take a break let's take a 4-minute break, just choosing challenging increments. Let's come back at 10:38. So I'll see y'all in a few minutes. I'll hop back on in a few minutes in case there are questions, but I'll see you in a few minutes. All right, welcome back to our final stretch. This is going to include the fastest conceptual introduction to k-means ever. And then we're going to use imports to help us quickly move forward with k-means. So I'm actually going to benefit from using imports for teaching today because we're going to skip a few steps by letting you import from a key an already wrangled the way that we need it for k-means version of penguins. All right, but k-means clustering. This is a type of cluster analysis which is unsupervised, meaning that there aren't specified groups or labels of data that we're trying to fit. It's just a way to try to explore groupings that exist when data, when we say, what happens if we try to identify k number of clusters based on multiple variables that exist within the data? In our case, that's going to be flipper length, body mass, bill depth, and bill length. And we're going to see if from those 4 variables, these things actually look like their natural clusters exist. Hint, yes, it's going to be pretty closely broken up by species. Like there's really pretty nicely defined clusters within that data. But k-means is commonly used to try to identify clusters or explore clusters that exist both in environmental sciences and biology like we have here, but also in things like finance and pharma and real estate to explore clusters that exist based on values of properties in multivariate data. Here's a disclaimer. This is a very surface level overview. There's a lot of considerations when you're doing k-means about things like scaling, distance metrics, how many cluster numbers you should use, and more. So just know going into this, this is kind of showing how to do it, but there's a whole bunch of critical thought and exploration that needs to go into doing k-means responsibly. All right, welcome to the cartoons. I am going to try to, I can't find my app. Let me try to hide myself so you can see this whole thing. Okay, here's just some quick slides about how k-means works. In k-means clustering, what we're trying to do is assign each observation in multivariate space to one of k, where k is a number of clusters based on a nearest cluster centroid. So imagine you have your actual observations from data. In this case, this would be in this multidimensional space where a point exists based on a penguin's bill depth, bill length, flipper length, and body mass. So they're each of those penguins in this multi-dimensional space based on 4 variables exists somewhere. And then we have cluster centroids, and we have as many, like you specify how many cluster centroids you're going to start with. There are ways of kind of exploring what might be a reasonable or advisable number of centroids. So that's our starting point. We got observations, we got centroids. We specify the number of clusters. In this case, in this cartoon and our example, we'll say 3. And then those centroids get shot randomly, usually, although you can specify where they go, get like shot into your multidimensional space. So they get hurled in there amongst your actual observations. And then what happens is they get randomly hurled into space, and each of your observations gets assigned temporarily to the closest centroid in that space. So your observations that are closest to centroid green are temporarily assigned green. Then you have purple and then pink. So they get temporarily assigned. But then what happens is those cluster centroids aren't automatically at the center of all of those observations. So the centroid actually moves to be at some central location determined by often Euclidean distances, but there are other metrics that actually, so it becomes at the center of this cluster of observations that were assigned to it. And you can see different kind of charts that are say like what is the within group mean squared error of the centroid from each of the points. So there are ways to figure out where this is and what the error or variance is associated with it. So those cluster centers move to be within their temporarily assigned group, but as soon as those cluster centers move, then some of the points are actually closer to a different centroid. So like these buddies looking all stressed out, those were initially closest to the green centroid, but now that the centroids have moved, now they're actually closest to the purple centroid. Not a problem. Then at this point, those points gets reassigned, those observations are reassigned to the current closest centroid. And then the process iterates. So now, again, the centroid moves. Those are recalculated based on the observations in their cluster. Once the centroid moves, some points, some observations will get reassigned. This iterative process of recalculate the cluster centroids, then reassign observations, then recalculate the cluster centroids. This goes on until nothing is moving. And at that point, we say, these are the cluster assignments of our different observations in the data set. There is your world's fastest conceptual introduction to what k-means is actually doing. Again, caveats abound. A lot of careful considerations about distance metrics and how many clusters you have. It is really important when doing k-means, but that is the overall intro to how the method is actually working. All right. So what I want to do now is in our follow along notebook, we've been happily working, and you'll see down in the section where we get to k-means, there's this whole section on prep the data, which is what this is doing is scaling the data so that variables just based on their units of measurements aren't overly weighted over other variables, and also converting this from an array of objects to an array of arrays, which is what the method that we're going to be using from the ml.js package actually wants. For the sake of time, we are going to use imports to help us out. So for the sake of time, I'm going to access from the key notebook, which I'm looking at here, but I'm going to share the URL. From the key notebook, I am going to go ahead and access the pre-prepped data. And you can look back at the key and actually see what these steps are. So all the steps you would do manually are included here. But I also know that there's an existing version in this key of that pre-processed data called Penguins Array. And that's what we're going to use moving forward with k-means to save ourselves some time. So here what I'm going to do, and to highlight the version that Cobus pointed out earlier in the chat, you could go back to the notebook that you want to import in and say like import penguins array from, and then give it this slug observable HQ DS workflows in JS session 2 key. But you can also go to the cell menu for that cell and choose copy import. And so that's another way that you can get what I could also write here, which I'm going to paste into a new JavaScript cell, which is to import penguins array from that key notebook. And this is just letting us get the version that we would have made through these different steps, just using imports. Imports are awesome. And if I want to look at what this looks like, I'm going to call penguins array and just take a look at what this actually looks like. This is an array of arrays of scaled values for my different variables, where now they've each been scaled to have a mean of 0 and a standard deviation of 1, using an import from another notebook that actually has a function for doing this scaling from Christoph Palmeyer. So I'm using imports here to really accelerate the work that I'm doing. I'll copy this import line 2 in case that's faster for folks. So if you copy this into a JavaScript line, then you will have the version that I'm going to be creating here, that I'm going to be working with for k-means. All right. So now, as a heads up, I have already imported used require to make sure this ml.js library is available for me in this notebook. The next step that I need to do is I'm going to actually run k-means. So I'm going to use the k-means method on that scaled data, giving it the number of cluster centroids. So this is what that'll look like. I'm going to say penguins clusters from the ML library, which is, if you look later in the notebook, and we did this in session 1, that's the name that I've given the ml.js library that we have access to here because we use require, which is down in the appendix section of this notebook. I'm going to use the k-means method, and then I'm just going to give it penguins array, and then this second term, the second argument, is how many clusters I'm going to create centroids for, and then iteratively determine which cluster each of my observations is assigned to. So if I run this, then you can see there's these different outputs for each of my penguins, what cluster it's assigned to. Yours might differ here. Just a heads up, since the centroids are randomly placed, you can have differences in outcomes. And there are ways that folks handle that too, like doing this multiple times and getting aggregate information. So you might get something different both in cluster assignment and the way the clusters are numbered. But I get these clusters, and if I want to just look at the clusters, then I can call penguins clusters and its output as a property called clusters. So this tells me for each of my penguins what cluster they're assigned to. So what I want to do now is, this is just an array of values, but it is in the order that my original array of objects is also in. So here, oh, and I think here what I did, I think I had filtered here to only include, some of my clusters. Oh boy, why are there only 165 here? Let me see. Penguins array 342. Are you all seeing 165 here too? Interesting. I feel like I had updated something here. Okay, but we're just gonna continue with this and see what happens. I think that what happens is my penguins array is being pulled from a version where I had filtered to only include female penguins, which might be a different version of the key than the one that I am looking at. But yeah, if Robert or Wayne have ideas on that, feel free to chime in. Okay, so these are my clusters. I think, again, I'm going to see what happens if I do penguins filter sex equals female. Yeah, okay, so here's what we're going to do. So this is, oh, thanks. Okay, so you'll get 342? That's fantastic. All right, what's my deal? Okay, so I'm going to show you, this is some weird version of the fork that I'm in. So I get 165. So that's because the version that I'm working with is currently using a version that only has the female penguins. All right, so that's what I'm doing. You all are working with a version where you get 342 clusters because you haven't filtered out the version that only has the female penguins in it. But I do want to show you what this looks like if we actually combine these things. So I want to have like all of my penguins data, and then I want to have all of my clusters. So if you have 165 cluster or 100, if you have 342 clusters, then this is what your code is going to look like. So you can write yours as like penguins, like clusters, and you are going to bind your penguins data, so your full data using penguins map, to a version of this oh boy. All right, y'all. I actually need to filter this first because it doesn't contain null values. So I'm going to first filter penguins to not contain any null values. So I'm going to say of sex is not equal to null. That gets me, oh, I already had this. Okay, penguins clust. I'll do penguins k-means. This is getting me to a version where it's not equal to null. I think there's also a version, since I imported, that has a dot here. But what you would want to do is you can use map to bind together those clusters that you created with the 342 penguins that do, oh, this is wrong. This is why. Bill length millimeters. Yeah, okay. Here's what you're going to do. You are going to create this version of penguins that doesn't have null values. And then what you can do is you are going to combine penguins k-means using map with this other array. So you can keep everything from penguins using the spread operator, but then you are also going to add to it your clusters. So you would do combining with it with the cluster values. This is getting a little fast at this point, but I promise it's all in the key. That you would then feed it from your penguins clusters, which returns the array of the different clusters. You're going to give it like from 0 to 341. This would bind it together with your clusters. This for me is breaking because I'll give it a name, cluster number. But this for me, I can see now that I have all of my penguins data, but also the cluster number which it was assigned to, which then means that I can create a plot of like the penguins data by bill length and bill depth, but then also look and see where those clusters exist. But what's really fascinating here is when I combine these is that we actually do see like all of the adeles pretty much, and we could do counts. This is also in the key. All of the adeles pretty much are in cluster 1. If we scroll down further, and I could look at this like in the data table cell, if I say penguins DTC, then I'll open this in a data table cell. Then all of these, we could really see like there's pretty discrete clustering here in terms of groups that appear. So for mine, again, yours can be different. My adeles are showing up almost entirely in cluster 1. But if I look at Gen2s, and again, this is interactive and filterable, they're almost entirely in cluster 2. If I look at Chinstrap, those are almost entirely, and I think this is where my misalignment is starting to happen. But if you look at the key, you'll see that these truly are like very discrete clusters that show up between these 3 different species, which again, like usually when you're doing k-means, you're not actually, you're not really like, you don't have a predefined group often that you are trying to like fit data to. But here, this is just a proof of concept that like, yes, we can do this k-means clustering. And yes, it looks like based on just those 4 variables for the bill dimensions, the flipper length, and the body mass, that actually they do exist in these pretty discrete clusters with very little overlap between the two, which is pretty cool. So, all right. So besides my borking of me using the wrong version, hopefully you all were able to actually see these different cluster assignments for k-means. In the key, there's also a visualization that I created, which actually uses text mark to label the different clusters, which I think really helps to clarify like how the penguin species really does seem to be broken up into these different clusters as we look across these 4 variables. So that is where I'm going to stop today. So in these last 2 sessions, we have gone through a lot of methods for getting data. We've inserted data table cell. We've used file attachments, imports, used D3 CSV today to get remote files. We used array methods and Arquero for data wrangling and transformation. We've used the chart cell and observable plot, and we used imports and inputs to access other visualizations and add interactivity with inputs to our charts. And the last thing that I want to show is embedding. So this is what we'll end on today. if I am in my notebook for any named cell, so I'm going to go back up to one of my charts and I'm going to give it a name. So you can pick one of your charts where you're showing chart code, and I'm going to name this like my chart. For any named cell, if I go up to the cell menu, you can see there's an option for embed. And I can choose both that chart and an input associated with it. And then you have different methods that you can actually use to publish that elsewhere. So here, for example, I'm going to copy this URL. And just to show that this is working, I'm going to open up a new tab, paste that in, and then I can see that in a brand new window, which could be an app or your blog or a post that you've created, that I've embedded both my interactive widget and the chart that I've created. So it's like one step to embed interactive visualizations that you've made in Observable to use them elsewhere. Just remember that they need to be named things. Otherwise, you'll see the embed option grayed out. Okay, so that is where we're stopping for session 2. Thank you so much for joining. One final picture of the Adelis at Torgerson Island. Thanks for hanging out with me and the penguins. As a reminder, our final session in the series, session 3, is Tuesday, July 25th. Next Tuesday, same time, 9 to 11. We'll keep expanding this toolkit that we have for different ways to work through data science workflows. Thanks again for joining. We'll look forward to seeing you in the next session. And the key is posted. We will also share it in a follow-up so that you can see all of those steps to get through the k-means to the final visualization. All right. Thanks, everybody. Have a good one.